Hello, welcome, there is Zmotion technology. Let's continue our quick start 17. Today, see trajectory look-ahead function of interpolation and corresponding commands. Interpolation motion's basic contents were talked in last lesson. You could review it, which includes how to achieve linear interpolation, all kinds of circular interpolations, etc. Okay, you may be confused what's the meaning of this theme. Before that, we should know one theory at first. The continuous interpolation motion. It belongs to advanced interpolation motion, not part 1 basic interpolation. One kind of motion in look ahead. Continuous motion means it will not stop between motions. That is, when motion 1 ends, it keeps moving trajectory 2 directly. The speed will not decrease to 0. In this way, motions can be achieved continuously and quickly. And its usage is very easy. Just set merges on to open continuous interpolation. Therefore, continuous interpolation is extremely popular in real processing. Please note it uses spindle axis parameters for interpolation. The spindle axis is the first one axis among used axes. Let's see one example. If we run one rectangle trajectory, like this, for motions are here. If we make it do continuous motion now, from the spindle axis speed curve, it can be seen it moves continuously until ends. The trajectory efficiency is higher than without continuous configuration. However, at this time, you may think about one question. Yes, there is one problem. Here, one corner exists between two motions, which means machine shock and shaking, and especially when the corner is not small. Even though the efficiency is considered, the processing accuracy becomes lower. In real machining, the result is really bad. For this situation, how to do? You may think don't make it continuous, like this. Of course, no shock anymore because each motion's end speed is 0. However, you see, it takes longer time than continuous motion. The motion becomes slow. If the efficiency is low, which will cause economic losses in a way. Then, is there any solution? Both situations have obvious problems. How to make it efficient under continuous interpolation, and solve the corner shock at the same time. Don't worry, Zmotion develops one function. That is, look ahead. It will automatically judge whether to make the corner speed decrease. Calculate one reasonable corner speed according to the path and configured corner condition. That is, for the path that meets corner condition. The configured reference speed will take effect immediately. This path speed will be limited within reference speed. Move at different speed. And in any acceleration and deceleration process, the speed will not exceed the accel and decel value that are set. But if not reach the condition range, no any changes. Through look ahead, corner shock problem can be solved easily. See the example. It processes speed smoothing at 3 corners. Compared to situation 1, no shock, safer, higher precision. Compared to situation 2, it takes less time, higher efficiency. Therefore, when look ahead and continuous motion are combined, the efficiency and the accuracy both are ensured. Same, there are many commands. Continuous motion is opened by this command, merge. Set it as on or off. Force speed, it is one reference speed. That is, when look ahead is processed, refer to this value for speed planning. The most important one is corner mode, corner configuration. And it has 3 modes, mode 2, mode 8, and mode 32. Each mode can achieve corresponding effects. Mode 2, make it automatically decelerate at the corner. Mode 8, automatically do speed limit for small circle. Mode 32, automatically do chamfering. And these modes can be superposed. For example, mode 2 and mode 8 are used together. Generally, corner configuration is done in the parameter initialization. And as we all know, it is used to smooth the corner speed. Therefore, it should be written at first. After that, edit corresponding motion path. Let's see these 3 modes one by one. Mode 2 firstly. It checks whether to do decelerate and how to do it. During the process, decel angle, stop angle will be used also. Starting deceleration angle and end deceleration angle. Please note the end angle is bigger. And their units are radian. Which means it needs to do unit transferring at first. Refer to this formula. But what they can do? Why they should be used? They are the deceleration conditions. That is, compare them with the real motion angle. The result will decide whether to decelerate. And 3 situations in total. Please see the graphic for clear understanding. At the beginning, the corner appears 2 continuous commands. Red lines are these 2 motion angles. Then, their angle, between next motion angle and the black dotted line is the reference angle. That is, the angle change range of these 2 continuous commands. At this time, when starting angle and end angle are configured. These 2 blue lines. It is time to do analysis whether to decelerate or not. When the next motion angle red one is within starting angle area. It is between this blue one and black dotted line. That is, when it is smaller than starting angle. It will not decelerate. If it is in the middle between starting angle and end angle. It will do geometric deceleration. The last situation, it exceeds the range. Decrease to 0 directly, then start another motion. Okay, rule is like this. Compare the angle and do corresponding action. About the corner speed value, it will refer to force speed, which is set by yourself. Please set one reasonable value. For example, when the reference angle closes to end angle, the value also should close to 0. It can be known mode 2 only does corner deceleration. It will not change the motion trajectory. Solve the machine shaking problem mainly. If your application appears machine shock, but no special needs on the speed. Corner mode 2 is perfect for that. Let's one example of mode 2. It can be seen 4 motions here. Make it without look ahead, only continuous at first. This is the composed interpolation trajectory. Between motion 1 and motion 2. There is 190 degrees corner. Between motion 2 and motion 3, one smaller angle. Between motion 3 and motion 4, one another smaller angle. Also, the speed curve is captured. Continuous interpolation is opened. Speeds are continuous. The blue one. VP speed, it is the spindle speed trajectory. 100 all the time. Then, see axis 0 and axis 1 separate speed. Between axis 0 speed and axis 1 speed, the acceleration is very big. A big shock on machine will be made. For motion 2 and motion 3, it is also big. Therefore, without look-ahead function, it is really not safe. Let's plus the corner mode for the same motion. Codes become this. Set the mode as 2. Set starting angle, end angle, and the corner deceleration reference speed. Also, check the curve. It can be seen the speed curve changes. The first corner, it is decreasing. Because the angle is too big, which is more than 45 degrees. Therefore, it will give one new speed for this trajectory according to force speed. The second corner, it closes to 45 degrees. It decreases a little. Third corner, it is a small angle and less than 15 degrees. See, no any deceleration. Spindle speed is continuous. Therefore, these 2 corners are decelerated through mode 2. Next, mode 8. This mode is mainly to limit the arc speed for smoothing. Speed limit radius full SP radius should be set at first. Because it is used to determine whether to do speed limit. When the radius is smaller than this value, the speed will be limited. But if the radius is larger, no any limit, it moves as usual. Also, set the force speed as reference speed limit. And the real speed limit can be obtained by this method. See corresponding example. Move the arc by these 2 commands. It can be seen one arc's radius is 50. Another radius is 100. They were talked in lesson 17 part 1. If you want to make it smooth, add speed limit function before moving. Set the mode as 8. Then, set one reference speed. That is, when the speed limit is produced, it will refer to this value. Next, set the speed limit radius. Here, 60 is configured. Obviously, the first arc motion's speed will be limited. Radius 50 is smaller than 60. The speed will become 100 by this formula calculation. Not the speed 200 anymore. And see the curve, it is the same. It is in the middle between two scales. One space means 200. However, the arc motion 2 moves at 200 still. 100 is larger than 60. Arc 2 will not be influenced by mode 8. Therefore, through speed limit, real arc processing can be smoother. The last mode, mode 32. It does automatic chamfering between two interpolation motions. It is easier because it only needs the chamfer radius Zmotion, which will take effect when the corner angle is not bigger than 90 degrees. Specifically, when the corner angle is 90 totally. Use the Zmotion radius value to do smoothing. When it is smaller than 90, the chamfer radius will be automatically calculated by the system. But it will not exceed the Zmotion value. It can be known, this chamfer is used for all axes of interpolation. Therefore, it changes the trajectory, not decreases the speed. Suit to occasions that need high speed, but no special requirement on accuracy. The example. Set the mode as 32 at first. Then, give one chamfer radius, 10. This 10 radius is used for all three motions. The corner between motion 1 and 2 is 90. It will do chamfering. And use this radius value 10. The corner of 2 and 3 doesn't reach 90. Its chamfering is smaller. The whole trajectory is softer. If you set one another bigger radius, it will be smoother. Therefore, please set it as needed value. All three modes are shown separately now. How about use them together? Like this, mode 2, mode 8, and mode 32 are written here, including their required parameters. Starting deceleration angle and end deceleration angle for mode 2. Speed limit radius for mode 8. The chamfer reference radius for mode 32. And the reference speed when they take effect. Then, edit motions. Here are 5 motions. For linear motions and 1 arc motion. See the effect. This is the trajectory curve. It can be seen corners between each two motions are not so big. They all do chamfer processing. And see the speed curve, which is more obvious. The first corner, it decelerates. The second corner, it also decelerates. The third one, without any change. But for last one, its speed is limited, which is smaller than the beginning speed. Let's move this trajectory in RT-sys directly. Open the RT-sys. Then copy the above shown example codes that include 3 modes together. Set the auto-run number. Connect to controller or simulator. OK, connected. Open oscilloscope tool, which can capture motion trajectory and speed curve. Here, we need 5 curves. Select 5 channels at first. Then, choose needed data. Axis 0 speed and distance. Axis 1 speed and distance. And the interpolation spindle speed. OK, now, parameters are configured. Start the scope directly. Download the program to trigger the scope. It can be seen it is moving. Now finish, let's check the curves. See speed curves at first. So, we can hide distance curves. And offset them for viewing clearly. Obviously, corners are smoother. The distance curve is also same. RTSys is our Zmotion own software. It can edit, debug, and diagnose programs. You could download it from website and view corresponding videos for learning at the same time. Today's part 2 is over. In a short, on the basis of part 1 interpolation motion knowledge, show you how to make the interpolation smoother, which is called look-ahead algorithm. when look-ahead and continuous functions are used. Trajectory can be more ideal. Safe, fast, and accurate. Thank you for your watching. And next part, Zmotions will be introduced. If you are interested in our products, or there are any questions, glad to talk with you. See you next time.